Our dear Senior 6 students, I welcome you all at Light Academy Secondary School e-learning platform. My name is Teacher Sewira Jimmy. Let me hope you are all okay. I'm going to take you through Senior 6 Mathematics Paper 2, and our topic today is errors. Let us first make a review of what we discussed in our previous presentations. Maximum absolute errors are, we shall start with that one in addition. Addition, you're seeing here A plus B. The maximum absolute error there is change in A plus change in B. And that one in subtraction, which is A minus B, it is change in A plus change in B, which is the same as the maximum absolute error in addition. Then maximum absolute error in multiplication, you're seeing multiplication here, AB, it is A times change in B plus B times change in A. Then in division, A over B, the maximum absolute error is A times change in B plus B times change in A over B squared. And that one in the power, which is A power P, it is P times A power P minus 1 times change in A. From there, we can continue to get relative errors. And relative error is absolute error over exact value. And then percentage error is relative error times 100. Let us look at our first example. Find the percentage error in 14.31 times 5.24. Our solution. Since here we have multiplication, we are going to use xy multiplication. I'm not saying that always use xy. Another person can decide to use AB, as we've seen in our previous slides. Now, xy. What is our x? Our x is 14.31. What is our y? Our y is 5.24. Now, if our x is 14.31, change in x will be, you just count these digits after decimal point, 1, 2. Those are the digits you're supposed to have after decimal point. 0 point is 0 point. You write those 2 zeros, then 5. Then here, y is 5.24. Change in y will be 0.005. Then, what is the maximum absolute error expression for the product? Here, since we have xy, how do we get that expression? We behave as if we are using the product rule from calculus. This is it. It will be x times change in y plus y times change in x. Then we substitute in. Our x is 14.32. It is there. Our change in y is here 0.05. Is there. Our y is 5.24 is there. Our change in x is here 0.05. Now when you feed this in the calculator, you come up with the answer 0.09775. That is our absolute error. Change in z is our error or absolute error. Relative error is absolute error over the exact. But now, so far, we've got the absolute error, the exact value, we've not got it yet. Now, we shall get the exact value next, which is 14.31 times 5.24, which is equal to 74.9844. Then we substitute back in our relative error expression. We substitute in this value, which is the absolute error we've just got from the previous slide, divided by the exact value we've just got here, and our answer is 1.303604483 times 10 power negative 3. Why is it that I'm not bothering to expand this. I'm not expanding this simply because this is not my final answer. It's just an intermediate value which is helping me reach the answer. Percentage error is relative error times 100. That means we pick that value which is not expanded from the previous slide, we multiply it by 100, which is 1.303604483 times 10 power negative 3, then multiply by 100, and the answer would be 0.130360448. This is our percentage error. Or we can try to reduce the decimal points by rounding it to at least 4 decimal places. When I say 4 decimal places, at least 4, that's a mathematical statement. You're free to write 5, you're free to write 6, 7, and so on. And here we've been looking for percentage error, and we are not putting here percentage simply because the word percentage is embedded in the question. That means we don't need to waste our time putting here percent. Now our example 2. If A is 3.2, B is 9.0, C is 12.12, and D is 2.6 to a given number of decimal places, find the absolute error and relative error in A plus B. That's the first part, Roman 1. Roman 2, B minus A. Roman 3, A B. Roman 4, C over D. Remember here we are getting two things, absolute error and relative error. Our first solution. Now here, the Roman 1 is talking of addition, A plus B. But it's adding A plus B. That means we have to pick there the values of A and values of B. Now, the value of A is 3.2. That means the error embedded in this, since we are having only one here, one figure here, we shall write 0 point, we write 10, then a 5. Then B is 9.0. The error involved in 9.0 is 0 point. Since we have only one digit this side, it will be, we write 10, then a digit 5. Then we get the expression for the absolute error in addition, which is change in A plus change in B. Then we substitute in to get the absolute error. The change in A is 0.05 plus change in B 0.05. The answer is 0.10. Then relative error is absolute error over the exact value. We've already got the absolute error, now we need the exact value. Since we are dealing with addition, we shall just add those two terms, A plus B, 3.2 plus 9.0, which is giving us 12.2. Then we substitute in the formula 0.10 over 12.2, which is taking us to 0.0081967. That is the end of our Roman 1. Then we go to Roman 2, because there we've answered, we've got the absolute error, and at the same time we've got the relative error, of which those were the demands of the question. Roman 2, given that we are given that B is equal to 9.0, that is from the question. From there, we can get the error in it, which is 0.05. Since it's one decimal point, that's why we are saying 10 here. Then B is 3.2. The error in it, since it's also having one decimal point, the error is 0.05. Then we are looking for the absolute error and relative error of subtraction, B minus A. Now let us first get the absolute error for subtraction. Is it change in B plus change in A? Then we substitute in, we are going to get the answer 0.1. Then relative error is absolute error over exact. Therefore, what is the exact? Which is 9.0 minus 3.2, since we are subtracting, which is equal to 5.8. Then we substitute in the relative error expression, which is 0.10 over 5.8, giving us 0.01724. Then Roman 3. Given A is 3.2, then error in A is 0.05, B is 9.0, then the error is still 0.05. Then here we are looking for the product AB. What is the absolute error expression? It is A times change in B plus B times change in A. Then we substitute in, our A is 3.2, our change in B is 0.05, our B is 9.0, our change in A is 0.05, giving, when you put that in the calculator, the final answer will be 0.61. And then relative error, we substitute in the formula absolute error over the exact value. And the exact value is 3.2 times 9.0, which is giving us 28.8. Then relative error is 0.61 over 28.8, taking us to 0.0211806. Roman 4, given C is 12.12, the error embedded in it is 0.005. Then D is 2.6, the error embedded in it is 0.05. Then we are looking for C over D. Then it will be the expression for the maximum absolute error. It will be D times change in C plus C times change in D over D squared. Then we substitute in. Our D is 2.6, our change in C is 0.05, our C is 12.12, our D is 0.05 over 2.6 squared. When you put that in the calculator, the answer is 0.091568. But we've not answered the question that is Roman 3 fully, because we've just got the absolute error. Now we need relative error. Relative error, which is the same absolute error over the exact value. That means we need the exact value first, and since we are dividing, we shall divide 0.12 divided by 2.6, which is giving us 4.661538. Then we substitute in the formula 0.091568 over 4.661538, giving us 0.0196433. That's our final answer, and we've fully answered our question, Roman 1 to Roman 4. Now let us go to this other method. Using the maximum and minimum method to calculate errors, we can use maximum and minimum method to calculate errors. Let me start with this example. If a diameter is given as 5 centimeters to the nearest centimeter, what do we mean by that? Now, you're given a diameter which is 5 centimeters. That means here, what is the error embedded in 5? 5 is a whole number. The error embedded in it is 0.5. How do we get the 0.5? We say that we count the digits we are seeing after decimal point. Here we have 0 of them. Then we say 0 point. We write the zeros equivalent to number of digits we are seeing after decimal point. Then a digit 5. Since here we are seeing 0 decimal points, that means we shall just say that the error involved is 0.5. Now, if the error involved in 5 is 0.5, therefore this 5 is in between 4.5 and 5.5. How do I get this? Now, I'll just say 0.5 beg your pardon, I'll just say 5 minus 0.5, that one will take me to 4.5. And then also I'll say 5 plus 0.5, that one will take me to 5.5. Or I'll just say the diameter D is equal to 5 plus or minus 0.5. And this 4.5 is what we call minimum value of the D, or of the diameter D. And this 5.5 is what we call maximum value. Then the 4.5, the minimum value, and 5.5, the maximum value, put in closed brackets. Closed brackets is what we call the interval within which the exact diameter D lies. Then 5 plus or minus 0.5 is what we call the limits. Those are the limits. No, I'm saying those are limits. I think you're hearing here, this is plural. That means we have more than one. I think when you add and when you subtract, those are two values. I'm right to say that that's plural. They are two values. And the range is written as 4.5 less or equal to D less or equal to 5.5. And finally, plus or minus 0.5 is what we call the error bounds. And that 0.5, we get it this way, that it is 0.5, which is got in the way that you just say 1 over 2 into 5.5. What is 5.5? This is our maximum value. Minus 4.5, this is our minimum value, which is equal to the error bound. That means when looking for the error bound, you just need to say 1 over 2 minus maximum value. Beg your pardon. 1 over 2 into maximum value minus minimum value. Maximum absolute error is a half maximum value minus minimum value. I think we've seen it from that previous slide. And the error bound is the same, which is a half maximum value minus minimum value. The following principles will be very useful when using this method. If we are to use a method of maximum and minimum method to get the errors, we need to have these principles in mind. The first one, maximum of A plus B. When I talk of maximum of A plus B, now whenever I talk of maximum, that means I'm looking for a big answer. And whenever I talk of minimum, that means I'm looking for a small answer. Now, when I'm looking for a big answer, when I'm adding two numbers, what do I expect you to do? I expect you to add big values. That means when you want a big answer in addition, just add big values. That means just get a big A plus a big B. That's why I'm saying maximum of A plus maximum of B. Then the minimum of A plus B. I say the minimum, that means I'm looking for a small answer. When I'm looking for a small answer of addition, that means I'll add two small things. That means I'll say minimum of A plus minimum of B. Then the second principle, maximum of A minus B. When I'm looking for a big answer of two values being subtracted, that means I'm supposed to first have maximum of A minus minimum. I think when I have a big answer minus a small answer, the answer which will remain will be big. Because originally we said we want a maximum. Then the minimum of A minus B. We minimize the A minus maximize B. When you minimize the first term and maximize the second term, obviously the final answer will be small. Then maximum AB. When you're looking for maximum of the product, that means multiply two big answers. There, I'll multiply maximum of A times maximum of B. I think that one is very clear. Minimum of AB. When you're looking for the minimum of the product, we want a small answer. That means multiply small values. Minimum of A times minimum of B. Roman 4. Maximum of A over B. When we are looking for the big answer of a quotient A over B, that means when we make the denominator very big, the answer is going to be very small. That one can't be. We are supposed to make the numerator very big and the denominator very small. That's why here you're seeing I'm saying is equal to maximum of A over minimum of B. Then minimum of A over B. If you want a small answer, that means obviously you need to make the numerator very small. Minimum of A, then the denominator very big, maximum of B. Example 1. Find the range of values within which the exact value of 6.23 times 3.45 is expected to lie, where all the numbers are rounded. Our solution. We shall start with the exact value. Exact value, since it's a product, we shall multiply 6.23 times 3.45, which is equal to 21.4935. Then maximum. We maximize 6.23 times 3.45. Now, when maximizing a product, that means we want a big answer after multiplying. That means we shall maximize the first number, then times maximize the second number. Maximizing is having this number plus its error. Even here, having this number plus its error, that is maximum. That's why here you're seeing 6.23 plus 0.005 times 3.45 plus 0.005. Why am I adding this value error 0.005? I think you agree with me that 6.23 is having the error 0.00, then a 5, 2 zeros, because we have two positions here, this and this. When you put that in the calculator, the answer is 21.5420. Then minimum. Minimizing 6.23 times 3.45. Now, if you're to minimize this, that means you have to minimize the first number times you minimize the second number. Minimizing this first number means subtract its error. Even this one, subtract its error, then multiply the outcomes. 6.23 minus its error 0.005, then times 3.45 minus its error 0.005 will give us 21.4451. Then we quote the formula: error bound is equal to a half maximum value minus minimum value. Then we substitute in is a half into our maximum value is 21.5420 minus 21.4451, which is equal to 0.04845. Then the limits of range of values. Limits, I said, are supposed to be 2. That means you pick the exact value plus or minus the error bound we've got. Therefore, now when you subtract, you're getting this lower bound. When you add, you're getting is this upper bound. That is our range of values. That's why I'm saying range is 21.3966 less or equal to exact value less or equal to 21.5904. Since the question wanted the range, that comes to the end of that question. Now that's our first number in our exercise. Let me give you some means to make you copy the question. Let me hope you've completed the first question. Now let us advance to the second slide to copy the second question. Let me hope you've completed copying that second question. Now we've gone through the errors, we've reminded ourselves the errors, and now we've seen the absolute error, the relative error, the percentage error. Then we've seen how we can use the maximum and minimum method to get the errors, and we've seen that the error bound is equal to a half maximum value minus minimum value. And then after that, we've seen how to get the range of values is just getting the exact value plus or minus the error bound. And after, when quoting it, we've seen how to quote it, that you quote on the left the minimum value less or equal to exact value less or equal to the maximum value. And before we conclude our presentation, in the next presentation, we shall look at linear interpolation and linear extrapolation. Thank you for listening.